We got the next question. Let me write the question down. Let I of x be equal to integral x positive 1 divided by x times of 1 positive x e raised to the power of x raised to the power of 2 times dx. X is greater than 0. We are given a condition. If limit x tending to infinity of I of x is equal to 0, then we are asked to find I of 1. So what I would do is I will consider I of x to be equal to integral x positive 1 over x times of 1 positive x times e raised to the power of x raised to the power of 2 times the dx. Now what I would do is I will multiply and divide by e raised to the power of x equal to integral x positive 1 times e raised to the power of x divided by x into e raised to the power of x times 1 positive x into e raised to the power of x raised to the power of 2 times the dx. Now I would make the following substitution. Let 1 positive x into e raised to the power of x be equal to t. I differentiate this. Differential of 1 is 0. Now you need to apply UV formula. So x times differential of e raised to the power of x positive e raised to the power of x times differential of x. That's going to be 1. That has to be multiplied with dx, and this would give me dt. So we got e raised to the power of x and e raised to the power of x. So take that e raised to the power of x out. So you got x positive 1 times dx is equal to dt. Go back to the question. The numerator is exactly that. So you have I of x, which we started off, is now rewritten as integral. In place of the numerator, you substitute dt. In place of the denominator, you have xe raised to the power of x. Now you got xe raised to the power of x. If you were to push this 1 to the other side, you have x times e raised to the power of x is equal to t negative 1. So substitute that t negative 1 times 1 positive x into e raised to the power of x. So 1 positive x into e raised to the power of x is nothing but t. So substitute that. So you have t squared. Now we will have to consider integrating dt over t squared times t negative 1. Now I will be using integration by parts. So for that I would consider 1 over t squared of t negative 1. I'm going to rewrite this in the following manner. A over t negative 1 positive bt positive c over t squared. Now if you were to cross multiply, you will have a times of t squared positive bt positive c of t negative 1. So this is equal to 1. Now what you can do is you can just start by putting t is equal to 0. So that would mean this goes up, this goes up, this goes up. So this means c is equal to negative 1. Outrightly you can get that value. Next you take put t is equal to positive 1. So this goes off if t is equal to positive 1. So that means you have a. This means a is equal to 1. So you got a and c. Just substitute that value. You can extract the value for b. So 1 is equal to a is 1. So you have t squared there. And you have to find the value of b. So this is going to be b times t. And c is negative 1. And then t is, or I would say just retain this t negative 1. So this is what you have got. Now you can just substitute any value for t. So if you were to take t is equal to negative 1, so that would give me a positive 1 here. T is equal to negative 1. So that's going to be negative b negative 1. T is negative 1, so it's going to be negative 2. So this is going to be 1. Negative b times negative 2 is positive 2b, positive 2, you have 1 there. 1 added with 2 is 3, so 1 negative 3 is equal to 2 times b. So this means negative 2 is equal to positive 2b, therefore b is equal to negative 1. So coming back to the integral, so I have assigned this to be equal to this, so this is going to be equal to a is 1, so it's going to be dt divided by t negative 1, b is negative 1, so followed by negative t divided by t squared times dt, and c is 1, let's say c is negative 1, so that will going to give me negative dt divided by t squared. So this is what we got. So this would give me ln of t negative 1, t and t gets cancelled, this would give me negative ln of t. Now t squared, I can write t squared in this following fashion. So you are supposed to integrate dt over t squared, right? So this is going to be t raised to the power of negative 2 times dt. You integrate this, you get t raised to the power of negative 2 positive 1 divided by negative 2 positive 1, which is t raised to the power of negative 1 divided by negative 1, which is 1 over t, and that would be the outcome, negative 1 over t. Now there is already a negative sign and this will become positive. So using ln of a negative b, this is going to be ln of t negative 1 divided by t positive 1 over t. But my t, where is my t? My t is 1 positive x into e power x. So this is going to be ln of 1 positive x into e power x negative 1 divided by 1 positive x into e raised to the power of x, right? Positive 1 over 1 positive x times e raised to the power of x. Of course arbitrary constant c is there. Now positive 1 negative 1 goes off, so this is going to be giving me, this is equal to ln of x into e raised to the power of x divided by 1 positive x into e raised to the power of x. Okay, positive 1 over 1 positive x into e raised to the power of x, positive c, this is my I of x. Now the question says as x is moving or tending towards infinity, ln of x is equal to 0. So this would mean you need to set x to be tending towards infinity. For that, what I'm going to do, I'm going to take a x out here. So this is ln of x times e raised to the power of x divided by x of 1 over x positive e raised to the power of x, positive 1 over 1 positive x into e raised to the power of x. Okay, positive arbitrary constancy. Now this x and this x is cancelled, and as x is moving towards infinity, what happens here? Our 1 over x will move towards 0. So this in turn would mean we have a 0 here followed by a 0 positive c, and on the left it's already given ln of x is equal to 0. So this would mean c is equal to 0. Now if c is equal to 0, you have I of x is equal to ln of x times e raised to the power of x divided by 1 positive x times e raised to the power of x, positive 1 over 1 positive x times e raised to the power of x. Now you are expected to find ln I of 1. So therefore I of 1 is equal to, substitute x is equal to 1 here. So this is going to be ln of E divided by 1 positive E, positive 1 over 1 positive 1 times E. Right, this is what you've got. Now what I would do is I will make the following simplification. This can be rewritten as ln of A over B. It's going to be ln of E, negative ln of 1 positive E, positive 1 over 1 positive E. Now ln of E is 1, so you have 1 negative ln of 1 positive E, positive 1 over 1 positive E. So you club these two together. Okay, so that would give you 1 positive 1 over 1 positive E, negative ln of 1 positive E. You take the LCM as 1 positive E, that will give you 1 positive E, positive 1 negative ln of 1 positive E. This is going to be 2 positive E over 1 positive E, negative ln of 1 positive E. What is this? This is I of 1, and that is the solution for this question. Okay.